Sorry for being late. I had some problem with the internet, but now we can continue. This is my name. I am at Morogoro Regional Center. So those who are in Morogoro, they should not hesitate to see me. Okay, so this is our first lecture, and it's going to be like some sort of an introductory lecture. We are going to look at the contents in Moodle, and then we have the WhatsApp group, which I believe you have already joined. And then we are going to have an overview of knowledge area number 1. I want to emphasize that there are several sources of information that we can use for this particular course. We start with the course outline, and we end up with the huge or the largest library in the world, which is internet resources. So don't just concentrate on studying by using course material in the model without going to the internet. Whatever you see in the model is just a summary. You can explore a lot of information when you go to the internet. The OUT model platform, this one is a must. I know some of you have not paid their fees and they cannot get into the model account. This is a very big mistake, because this particular lecture which we are doing now is just very superficial. The contents are included in your model, and you are going to see the type of content that are available. We also have online library resources. If you click at the OUT website library link, you should be able to see a lot of notes which can be used to give you a lot of information on this particular course. YouTube. I know most of you are very conversant about the items which are present in the YouTube, but instead of just looking at social issues, there is a lot of educational material in the YouTube. Just write whatever terminology, and you will see a lot of additional material in the YouTube. And then there are some search engines where you can get some textbook, like this one, PDF drive. In each minute, they normally download a lot of, upload a lot of material. So please don't just rely on the search engine of Google. You can also use these other specialized search engines. And by the way, I'm going to upload this particular presentation in the WhatsApp group and also in our model course page, so you don't have to write if I'm going very fast. Then I know some of you may not be having a scientific calculator. Most of you have some laptops, but you cannot get into the examination room with the laptop. So I advise you to buy a scientific calculator, and the Casio FX series. These are very easy to use, and I've tried to put some demonstration in your model page in terms of video that can guide you on how to use the Casio series. You need to practice and also be able to master all the functions which are important for this particular course. And if you see it will be very, very easy for you to study, do calculation once you have mastered the scientific calculator. But you cannot, master the scientific calculator if you don't do practice. Take a lot of...
Sorry, sir, I came to get your sound, right?
Pardon?
There's some problems.
Hello? I did not hear you, but I believe the others are able to hear. If not, please let me know. Okay? As I mentioned before, the internet is our largest library. Please don't hesitate to use the internet. Just check any terminology, Google, put it in the YouTube, you'll be able to see very good information. And then another advice is don't study alone. Even if you are separated geographically, you can use the WhatsApp video call to interact, or you can use Zoom. Zoom is free for 40 minutes. Make and participate in discussion groups. Even if you have a group of 3, that should be quite okay. And then do a lot of exercise. Start with the past paper questions. I can give you some questions from past papers. There are several questions normally use section, area, or with, module 1. My internet, I'm told, is not stable, but I'm still connected. So when you open your model page, you will see some course information or course outline. This is very important. And I'm going to show you where you can see this one in my page. And then we have organized some lecture notes. This particular lecture will be on introduction, frequency distribution, and display. And then you are going to see a lot of other resources like PowerPoint presentation, links to YouTube videos, and so on. So if you open your model page, this is what you are going to see. Course objectives, and then at the bottom here, under the course objectives,
so we are going to see various issues on this knowledge area. To start with introduction to nutrition, what is nutrition?
Keep it assist you. Make sure that somebody has seen the course information, which contain a lot of description. Like this is the example of what you are going to see in the course outline. Part number 1, or knowledge area number 1, introduction to statistics and descriptive statistics. You are going to see that we have divided the course into 6 knowledge areas, and here I call them part 1, part 2, 3, 4, 5, and 6. Okay? The first 3 are supposed to be covered before you sit for your test. And then all 6 should be covered before you attempt your final exam. Now, if you open part number 1, introductory introduction, frequency distribution, and data display, this is what you are going to see. First, you are going to see the lecture number 1, lecture number 2. These are supposed to be the title of the 2 lectures which are contained in part 1 or knowledge area 1 of this course. And then if you look at the content, you have lecture notes, lecture number 1, and then you have a lecture PowerPoint, and then you have a link which will take you to one of the video which I judge to be very good for you on data display. And then you go to lecture number 2. Under lecture number 2, you should also be able to see a PowerPoint presentation and a link to another resource from the internet. Okay, we have a WhatsApp group. Those who have not joined the WhatsApp group, I'm going to type my number in the chat, or maybe I should just mention my number so that we don't become disconnected. My number is 0718133820. And then at the end, I'm going to post this one in the chat. So if you are not able to join the WhatsApp group, send me a message, and then I'm going to give you the link to the WhatsApp group. But remember that our WhatsApp group is strictly for academic purposes. Don't post whatever you want, a loan board or whatever, no. We just want academic issues. And I prefer that you use English, but sometimes I can close my eye and allow you to use Kiswahili. Okay, somebody says repeat the number. I'm going to type in the chat. So if you go to the chat, you should be able to see my number. Okay? It's very important. If you are stuck, you write a message in the group. There are some individuals who have already passed this particular course. They are there to help you. I can also see it because most of the time I am online and I can respond to your queries. Okay, so now we go to a brief introduction of knowledge area number 1. I know most of you have not gone through the notes, but it doesn't matter. You just follow and hopefully you get something. So we'll start with the introduction of statistics and the classification of data, compilation of data, and then we are going to touch something about frequency distribution. So here we are going to look at what is statistics. And if you remember, this is one of the items that appear in the course description, the document that I cut something and showed to you. And then we have type of statistics. We have something called descriptive statistics, and then another one called inferential statistics. We are going to cover these ones. Okay, so what is statistics? Statistics has 2 meanings. Meaning number 1 is numerical information. In singular form, it is statistic without an S, but plural form is statistics. So if you give some information like the population in Morogoro is 1 million, that 1 million with other people. Okay? Another meaning which we normally use in the context of this particular course is a branch of science within applied mathematics, but don't be scared. There is not any complicated calculations or whatever. We only have divisions, multiplication, and the addition. Simple, nothing like calculus or whatever. So it's a branch of science within applied mathematics that deals with collection of methods. And here you need to be very careful. This course will include a lot of methods and techniques. They share something, but it's just a collection which have been placed together in one course. And these techniques or methods will allow you to plan an experiment, to collect data, and once you get the data, it will allow you to organize, to summarize, present, analyze, and interpret whatever result you get from your analysis. And once you have done everything, then you can make some effective decision based on what you have done. So there is this term biometry or biostatistics or statistics. When you see the bio here, this is application of statistics to solve biological problems. Okay? So we are trying to distinguish whatever we are studying and focus on application to solve biological problems. And then when you hear about experiment, this one is a planned inquiry or activity. The key word here is planned. You don't just do an experiment without any plan. There has to be a set of instruction or blueprint or proposal that you're going to implement in your experiment. So the aim of the experiment will be to get some new information if we don't have that information, or you may want to confirm or deny some certain previous information. If somebody comes with a particular product and claim that the product is better than the product that you used to use, then you need to confirm by doing some experiment and test whether that new product is better than the old product that is being used. Okay, now you may wonder, why are you compelled to study this particular course? I understand this course is a core course. Yes, this is a very, very important course, and it's a cross-cutting course. It's taught in many programs at the OUT. Your program, Food and Nutrition, BSc General, BSc Environment, whatever, they normally have some element of statistics. The main difference is on scope and the type of examples that are used. But as I told you, this one is simple mathematics, applied mathematics. So you don't need a lot of knowledge to be able to master the course. Just simple algebra is sufficient. Addition, multiplication, that is all. So these are some of the courses which are taught at the university. This one, I know it has changed. They don't use this one, but they call it educational statistics. Then Faculty of Arts, Economics, they normally have introduction to statistics and mathematics for economists. Those who are doing mathematics, they have this probability and statistics. And then they have another course called Advanced Statistics, Design and Analysis. And for your case, you have this one. Another group which is normally paired with you. They have this course called biometry stroke biostatistics with two alternative codes. Then you may ask yourself, why should we bother to study statistics? Well, in the world, there is a lot of variability. Different products are marketed, and if you look at the product, there is a lot of variability. So you, as a scientist, you need to measure, summarize, and understand the variability. Another reason is we want you to draw valid conclusions from data. Whenever you do an experiment, you need to be confident and realize that the difference that you see between treatments is really and not due to chance. Okay? If you see a pattern, then that pattern should be meaningful. And we also study statistics in order to be able to plan some good experiment and surveys, because as researchers, most of the time we'll be required to find some new information or to confirm or deny some existing information. And then the other reason is we normally test hypotheses or assumption about something, and normally we compare groups. For instance, we may be having a new drug against malaria, and the manufacturers will be claiming that the drug is better than the old one. So you need to prove this one by doing some experiment and a test of hypothesis, so that when you provide your answer, you'll be supported by the hypothesis. And sometimes we're subjected to very complex biological data, so we need to summarize the information. We need to draw some conclusion based on a lot of data that we have obtained. I normally give you an example of the census data. You remember very recently, we were counted, we filled one page for each household with some important information. Now, can you imagine how many households are present in Tanzania? If we were to put all these sheets in one room, we draw some conclusion based on a huge amount of data like that of a census. And then we study statistics so that we can communicate our findings or results more clearly or in a better way to our audience. But then we also learn statistics in order to avoid the wrong conclusion. You are given a product, and then you are supposed to confirm whether the product is working or is not working as compared to another product. So if you do proper experiment, then you should be able to analyze your data and draw very good conclusions based on the support that you got from your experiment. Okay, so now we go to type of statistics. There is one branch called descriptive statistics, and then another one called inferential statistics. Descriptive, from the word description, this one will cover planning of experiment, collection of data, organizing your data, summarizing, and presenting a summary of the data. So you just describe what you have collected. But then, with inferential statistics, inferential came from infer, giving inference or assumption based on sample information. So this one extends the scope of descriptive statistics by analyzing the data, interpreting the data, and then drawing conclusions from the analysis and interpretation of the data. For instance, now that we have collected the census data from Tanzania, and then we summarize, for instance, age of, no, not age, maybe number of children. We summarize by only calculating the mean of each household. We calculate the mean of each household, maybe for each region, Kigoma against maybe Kilimanjaro. I'm just giving an examples, don't be offended. And then we come up with mean number of children in households of districts in Kilimanjaro and Kigoma. And then by chance, we notice that the mean number of children per household in Kigoma is maybe 6, okay? And remember, when you hear a mean of 6, it means that there are some households which have less than 6 and others who have more than 6. But then if we find out that the mean number of children from Kilimanjaro is only 2, why are households in Kilimanjaro having very few children as compared to households in Kigoma? Then for that case, we have summarized the data by calculating the mean. We have presented the data by giving the mean of each district and the mean of the region. Now we go and do inferential statistics, where we use probability to analyze the data and try to answer the question of, are the two means of Kilimanjaro and Kigoma different, regardless of the fact that we see 6 is larger compared to 2. But then we need to confirm by doing inferential statistics, and then we are going to look at table probability, and then we are going to come up with a solid conclusion that the number of children per household in Kilimanjaro is less than that of Kigoma. Okay, so I hope you can follow. We planned our experiment by planning the census, we collected the data, we summarized the data, and then we presented the mean of each particular variable. During census, we have so many issues that are going to be collected: age, number of individuals, whatever. We present that one, and then we see some trends in our data. That trend will prompt us to do additional testing and confirm whether there are some difference or some relationship between the different variables. Okay, so if we look at descriptive statistics, these are procedures that describe, organize, and summarize the main characteristics of the sample data. For the case of census, we don't do a sample, we normally collect everything from the population. But most of the time, we normally work with samples. We don't work with the population. How do we organize the data? How do we summarize the data? We are going to calculate means, range. I was supposed to have a comma here. Standard deviation, frequency, tables, and so on. How do we present the data to the audience? We can use tables, charts, histogram, depending on suitability of each particular tool for the kind of data that you have. If you have very huge amount of information, then you cannot use a chart. The chart will be crowded. So it's better to use a table, and then the readers can easily go through the table and decide to pick some trends while they're looking at the table. Okay, so we normally summarize by using mean and standard deviation and another concept called the standard error of the mean. These are very simple issues, but I become offended when we ask you in the exam and you see that somebody has passed through the course, but he or she cannot even do a calculation of standard deviation. And this one you always will appear in the exam because standard deviation is a key concept of statistics. You have and you must be able to calculate the standard deviation. Some of you have done some courses in the past, and you know there are different ways of calculating standard deviation, but I prefer that you learn the shortcut method. I prefer that you learn how to use scientific calculators, and then this will be able, will help you to do the calculation very fast and without any possibility of making some errors in the calculation. Okay, so we start with the mean. This one, you can even close your eyes and assume that you have already mastered how to calculate the mean. The mean is also called arithmetic average. This one is an average of a set of scores. You know this one. You add all the scores, you divide by the number of scores, and you get the mean. So no problem. But then you need to learn about the properties of the mean. This is very important because the mean is one of the most important item in statistics that is used to summarize information. Like the example which I gave you about number of children in households in Tanzania, you cannot present the number of every guy who was interviewed. That will not be possible. So we normally use average. You add all the numbers of children, all the households, and then you calculate the mean. So one mean can be representing one district. So for Kigoma, you may be having maybe less than 10 means from less than 10 district of Kigoma. Okay? So every set of interval level or ratio level data normally has a mean. We are going to look later about what is an interval level and what is a ratio level. They always have a mean. The mean is calculated by using all the values in the data set. So you cannot skip some of the household when you calculate the mean. There are some other parameters which do not require that you use all the individuals in your data set. The mean is the only measure of central tendency where the sum of the deviation of each value from the mean is always 0. I know this one may not be understood at this particular point, but maybe let me go back to the numbers. Okay, suppose we have a 5 data set, 1, 2, 3, 4, and 5. Okay, what we are saying here is this is the mean of the data set 3. So if you take 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3, and then you add the differences, the difference will be 0. Why is it 0? Because suppose the mean is 3, 1 minus 3 will be a negative value, 2 minus 3 will be a negative value, and this one will be a 0, but this will be positive. If you add them, then you end up getting a 0. So we are saying this is the only measure of central tendence where the sum of the deviation of each value from the mean of that data set is always going to be 0. The mean is useful when you compare 2 or more population, like the example which I gave you of census. We were able to compare the number of children in households of Kigoma against those of Kilimanjaro. However, one of the weaknesses of the mean is susceptible to the influence of outliers. By outliers, we mean some data that is a little bit abnormal or a little bit extreme as compared to data from most of the members. Now, if I go back to the example of a number of children in households, we say the average is 6 for Kigoma and 3 for Kilimanjaro. But suppose in Kigoma, there were so many guys who were polygamists. Maybe they have children up to 30. One person may be having 30 children. That guy with 30 will pull the mean from 6 maybe all the way to another number because this guy is an extreme deviant of the population. So remember that sometimes when you do your calculation, you need to take out outliers because this will affect your mean. And maybe you can take some example, like the example which I gave you of 1, 2, up to 5. If you add another figure like 30, 30 plus 15 equals to how much? 30 plus 15. This one will come to 45. And now we had 5 individuals, but we have added somebody who has 30. 45 divided by 6. I'm tired, I cannot perform this calculation without calculator, but I'm going to use my calculator here. 45 divided by 6 equals to 7.5. Okay? So can you imagine, with the data that we had before, 1, 2, 3, 4, and 5, the mean was only 3. But once we added something that is extremely different from the rest, like 30, the mean came to 7.5. I hope you follow. So always be on guard when you do an experiment and you see some odd value which is so different from other values. Maybe you should just remove that one as an outlier because that one is going to affect your mean. Okay? Now, I did not touch the other measures of central tendence like range or mode or No, the mode. Okay? But that one you can read. Now we go to another concept called measures of dispersion. Dispersion is exactly the same as variability. Okay? What does it mean? Dispersion means the spread of your data around the mean. Okay? How do the different individuals deviate or vary from their mean? The example that we have used is a very simple example. We had 1, 2, 3, 4, and 5, and the mean is 3. So the distance between 3 and the other extreme guys, that is what we call variability. Variability is said to be low when the values are very similar or they are very close to their mean. Variability is said to be very high if the values are not close to their mean. Okay? This issue of variability is a key concept in statistics because naturally, most of the issues that you are going to encounter will be having some variability. Okay? There is a concept called variance, which is essentially from variability and the standard deviation. These are the most important concept in statistics. Variance and standard deviation are related. The square root of variance equals to standard deviation. Or if you square standard deviation, then you get the variance. And we are going to learn this one when we go to part 2 of this course, which will deal with inferential statistics. And we are going to touch about lectures on hypothesis testing. Okay? So dispersion measures the variability within the data set by measuring how spread out a distribution is. It's an important concept for interval ratio variables, and this one include items like height, weight, or whatever. So now I want us to look at how do we calculate standard deviation. This is the most common measure of spread. There are some other measures, but this one is the most important measure of dispersion. The mean was a measure of central tendence, how the data are grouped close to their mean. But this one is the measure of dispersion. How far are the different data or individual from their mean? As I said before, standard deviation is the square root of the variance. Okay, those who have forgotten, this is supposed to be the square root symbol. Okay, so sometimes I trick you in the exam. I don't give you a standard deviation, I give you the variance. And those guys who have forgotten about the relationship between variance and standard deviation will be crying to find out what is the standard deviation. But this is very simple. Okay, so now this is the formula. I know when you look at this formula, you become scared. But when we do a worked example, you will see that this formula is very simple. So I'm going to skip and go to the next slide. Okay? So now we look again at the formula. This is the formula for calculating standard deviation, and this is what I call the shortcut formula. Suppose we have a data set of 1, 2, 3, 4, and 5, like the way we use for the mean. We have 5 data sets, no, 5 individuals, 1, 2, 3, 4, 5, okay? Now we go to the formula. We say the standard deviation is a square root of the variance. So we calculate the variance and then we take a square root to get the standard deviation. Now this one should not scare you. You'll become masters very shortly. This is called sum of x squared. Sum of x squared means you take 1, you square it, you add with 2 squared, 3 squared, 4 squared, 5 squared. In the end, the actual value is 55. Okay? So this is a sum of all individuals squared but added together up to the end. That's why we say sum. Sum equals to total. So this entity here means sum or total of x squared or x squares. Okay? And then the other one is called the sum of x, and then you have a bracket squared. Do you see now the square is outside of the bracket? So first, you calculate the sum of x, which is 1 plus 2 plus 3 plus 4 plus 5, you get 15. Okay? Just like the way we got it from the calculation of means. And then here you are told that you need to square that particular sum of x. So you take 15, you square it, and you get 225. So 225 is sum of x squared. It's different from this one, which was individual sum of individual squares of the members. I hope you can follow. Okay? So the first part, sum of x squared divided by n, okay? We have not divided by n. We only have the 15 squared here. Now you plug this one in your formula. Sum of x squared is here, 55, this one, minus 15, which is sum of x square divided by 5. Where did we get the 5? 5 is n, or the number of individuals that made up that data set. So when you do a calculation like this one, don't panic. Don't start with the 55. Just simplify this part. 15 squared, you get 225. Divide by 5, you get 45. Okay? Now you put this one like the way they appear here. 5 minus 1, this is what we call degree of freedom. We normally take out 1 from the n. 5 minus 1 equals to 4. Again, don't rush. Do this calculation, you get 10. Divide by 1,000, they don't have the square root function. So you need to buy a scientific calculator. The answer is 1.58. 1.58 Now, those who are going to bother to acquire some scientific calculators, the scientific calculator is so good. You just put 1, 2, 3, 4, 5, and then you press a button. I want standard deviation, it will give you. I want sum of x squared, it will give you. I want sum of x, it will give you. Very simple. Now you can fool the examiner by drawing out from the calculator the sum of x squared, sum of x, and then you plug them in the formula. Well done. You are done. Okay? This one, I'm telling you, you have to master it. You have to claim this particular formula. Whether you like it or you don't like it, you cannot study statistics if you cannot calculate standard deviation. It's a very important concept. And remember that in real life situation, you may not be getting simple numbers like this one. We'll give you some horrible numbers, 11.3, 12.2, whatever, not having simple numbers like this one. Okay, I hope you have understood how to calculate the standard deviation, and you need to do a lot of practice to be able to master the techniques. Now we go to classification of data. I remember I mentioned items like interval and ratio scale, but then you guys may not be very conversant about the type or classification of data. So data can be classified according to the type of variable, discontinuous or discrete and continuous. Or you can classify data according to scales and level of measurement, where you may be having nominal, ordinal, ranking scale, interval, and ratio scale. We are going to look at this one briefly. Don't be put off. Okay, so we go to type of variables. There are two basic type of variable, qualitative and quantitative. Qualitative, these are non-numeric type of variables or attributes like sex, names, color, and so on. Okay? These are qualitative. Quantitative, these are normally numeric in nature. Example, numbers and the proportions. Okay? And then if we look at quantitative variables, we say these are numbers. They can either be discontinuous without any decimal, discrete, or continuous. If somebody asks you to count number of individuals who have boarded a particular bus, you cannot say there are 8.1 individuals. You always say a whole number. There are 20 passengers, 13 passengers. Those are discrete variables, quantitative but discrete because they are discontinuous. Okay? So these are values, observations that are distinct and separate. They can be counted, 1, 2, 3, and so on. Whereas continuous, these are the opposite of discrete. These are variables that can assume any value within a range. For instance, weight of individual, height, speed, and so on. Somebody can be 45.8 kilogram. You see the 0.8? This is continuous. 76.4 kilogram. Okay? So these discrete data are normally counted, whereas continuous data is normally measured. Okay? How many kilograms of sugar? How many liters of water? But when it comes to how many bottles then you count the bottles. You don't weigh or measure the number of bottles. Okay, this one is a little bit small. It looks crowded, but don't worry, we'll go slowly and you'll be able to understand the concept. Okay, there are two arrows, this one and then this one. If you go from qualitative going down to more quantitative, you provide more information as compared to qualitative. Okay, so from these scales of measurement, if you start with the nominal and you go down, you provide more information and you become more quantitative. Okay, so let's start with the first row. There is a scale which is called the nominal. This one came from names. This includes names, labels, categories like gender, male, female, ethnicity, religion, smokers against non-smokers. These are categories. Measurement scales. One is called interval, and then the other one is called the ratio. Here, you have order or ranking. There are equal intervals between the individuals, but there is no true 0 point. For instance, when you look at a temperature scale, I'm sorry I've used an old term here because the book is from an American author. I should have used Celsius. Okay, so if you look at temperature, 0 temperature is not a true 0. 0 is a measurement of an interval type of data. You can have -1, -2, okay? But then we have another type called the ratio, scale of measurement. Here you have an order or ranking, equal intervals between observation, but there is a true 0 point. If you say the weight of a person is 0, it means the guy is that cannot be a person, sorry. 0 kilograms of sugar, it means there is nothing in that weighing machine. Okay? Height, 0 centimeter, it means nothing. Reaction time, 0. It's possible to have a 0. But then you have an order of quantitative nature. Okay, so the measurement of scale from nominal to ratio, you provide more information, you become more quantitative. Okay, I'm told we have eaten 5 minutes of our time, but let me see how far we can go before we become kicked out of the Zoom. Compilation of data. There are different ways you can compile data. You can use tables, pie chart, bar graphs, and I put a lot of examples in your model. I also put a presentation. So please go to your model and then look at how we can compile data. Measurement, you can use histograms or frequency polygon, and again, I put some notes and videos, so I'm not going to look at this one. The last item is frequency distribution. What is the frequency distribution? What are the shape of the distribution? How do you construct a frequency distribution? How do you present frequency distribution? Again, I request you to look at the video and the PowerPoint in your Moodle account, because this one is detailed in your notes.